Hello, my name is Dr. Ruben Fukwa. I'm a senior lecturer in the Department of Chemistry and Polymer Science, and today I want to tell you about some of the program offerings that we have in our department. So, as an icebreaker, the question would be, why chemistry? Well, when you woke up this morning, you had encounters with several things that are dependent on chemical processes. For example, if you value your oral hygiene like I do, you would have used a toothpaste. You would have used a bath soap or a hair shampoo or some other cleaning product. And if you drove to work or if to school, you would have been in a motorized vehicle that depends on some fossil fuel that would have been processed by a chemical process as well. If you walked to school, for example, the food that you ate to give you the energy to power your movements to wherever you were going, that also would have had encounters with some chemical process of some sort or another. You would have needed an agrochemical that is needed to make pesticides, for example, to make sure that the food production goes normal. So if you think about it that way, then you realize that chemistry is all around us. And it's one of the most interesting things that you can do when you come to university. So from what we've just discussed, what you realize is chemistry is the central science. It intersects with just about everything that you find and that you will study when you get here. Chemistry intersects with biochemistry, it intersects with physiology, environmental sciences, you name it. And if you're in grade 12 and you're thinking, what would I like to be when I grow up? Well, you want to have a job of sorts. You want to be employed, you want to be gainfully employed, you want to live a meaningful life, contributing to society, and you can ask another question. What if I do a chemistry degree, what could I do with this? Well, there are many things that you can do with this, right? And there's a whole long list. I could read off that list, but you can have a look yourself. You could work as a research development scientist, looking at things. How can we improve a chemical product? How can we make something work better? You could be a marine chemist, you could be a biochemist, you could be a technologist. All of these things are available to you with a chemistry degree. And one of the stereotypes that you have is, oh, if I do chemistry, am I restricted to a lab bench? Well, that is actually not the case. There are many interesting variations that are out there that you can also do with a chemistry degree. Once you have tackled the chemistry degree, it equips you with a very important skill to say, what is the problem that I'm looking at? You are trained and you're equipped to learn to look at situations and to ask, what is the problem? And that essentially prepares you to tackle so many different things. For example, some things that we may not even think of. You could actually have a career in law as a patent scientist. That, if you have a chemistry degree, then you now have the know-how to say, oh, what is going on here? Can you read a scientific document that is written at a very highly technical level and interpret it properly within the prescripts of the law? Then you need a background like this in chemistry. Nowadays, in lots of cases, people are encouraged to try and make value out of some of the knowledge that we create. So you could look at a career in entrepreneurship. That is also very important. You could be a journalist with a background in chemistry. Then you can look at very technical details at a very high level, and that is also very, very important. And you will see from this slide, which is very busy, but I think it's a very, very important slide. It also shows you that the chemical industry in South Africa is one of the biggest earners that we have in this country, generating lots of revenue. That is important for this country. South Africa has one of the most industrialized, in fact, it has the most industrialized and developed and diversified chemical industry that you find in Africa. And that means there is a lot of scope to find employment after you have finished your chemistry degree. So the structure that we have is you qualify for your BSc in chemistry. We have three main focal areas. Firstly, in our department, which is the Department of Chemistry and Polymer Science, we have this long name because we do actually have a very strong offering in chemistry and in polymer science. In fact, ours is the only department that offers a comprehensive program, undergraduate program in polymer science as well. So if you pick on this focal area, chemistry and polymer science, you could qualify for an honors program in chemistry, or you can qualify for an honors program in polymer science. You could also pick a focal area in chemical biology. This can lead you towards an honors program that can take you to honors chemistry or an honors in biochemistry. Or very recently, in 2024, a new focal area. This one is not based in chemistry. It's an interdisciplinary program, but that we refer to as applied medicinal chemistry. If you take this, it can lead you to a focal area that allows you to do physiology in your honors, or to look at chemistry in your honors. We have a new focal area on applied and sustainable chemistry, where we are going to look at green and sustainable chemistry that is also offered under the chemistry and polymer science. Essentially, what you need to do to qualify for university is you need to have very good passes in your mathematics and in your physical sciences. This is very, very important. The details are very nicely laid out, and when you do a BSc program in chemistry and you do well enough, then you qualify for a BSc honors in chemistry, then you can be registered as a chemist with the South African Chemical Institute. But once you've done that, in most cases, what you will find is the bug to look deeper and to dig deeper and pursue a much higher qualification, an MSc in chemistry or polymer science. It bites and it doesn't let go easily. So you can then pursue an MSc in chemistry, and from that point onwards, you can also pursue a PhD in chemistry. All of these details are very nicely laid out in our yearbook, which will happily provide a link in coming slides. So I mentioned that we have a very new program that in green and sustainable chemistry that is offered under our applied and sustainable chemistry focal area. And you can ask, why green and sustainable? Well, we spoke about this, that any moment in life you're intersecting with a chemistry product, something that would have had to have some processing of some sort or another. Now, the question you can ask is, if, for example, I've used a disposable cup to have a quick cup of coffee, what happens to the cup after I'm done? Where does it go? I put it in the bin nicely. Where does it go? Does it go to a landfill, or is it going to be incinerated, or is it going to be recycled? So these are very, very important questions to ask. And what we need to think about is what goes into this product. What is its life cycle? What do we leave behind? In a lot of cases, what we are finding is some of this waste is not handled properly. The ways we interact with chemical processes and chemical products need to be improved to improve the health of our planet. If we don't do that, then we will have problems. And what we need to do is to minimize these problems. So we can then think of green chemistry, which is what this tries to solve. So green chemistry essentially entails the design of chemical products and processes that aim to reduce and eliminate the use and generation of hazardous substances. And this is very important, because if we don't actually start doing something about this, then the health of the planet is going to be affected in the long term. It's already being affected as we speak. And sustainability, why? Why green and sustainability? Well, whilst we are doing what we do with all the chemical processes that are going on at the moment, we need to do it in a sustainable way, in such a way that whilst we're meeting our own needs, we should not compromise the needs of future generations to meet their own needs. So for what we are trying to achieve, green and sustainability, they have to go together. A process could be green, but it may not be sustainable, and vice versa. You may have a process that's sustainable, but it generates harmful substances or gases afterwards, and that is a problem. So we need this to actually go together, and that is very important. And the structure, this slide shows you the structure of our offering. We will introduce you to green chemistry, the concept, the tools, and look at some of the things that we can actually do to try and improve the chemical processes that are currently there. What type of catalysis meets the objectives of green and sustainability, renewable materials or sustainable feedstocks, and sustainable polymer materials. All of these things we'll have a look at in this module. sometime in 1991, the principles of green chemistry were put together. There's quite a long list that is very detailed, and this is something that you must find some time to have a look at. So whilst in everyday life we'll say, try to manage waste, clean something up, dispose of it properly, and then maybe it ends up in a landfill or it gets incinerated. From green chemistry principles, we say, can we prevent waste? Right. So rather than circumstantial control, we need to be deliberate about this. So where we could say, maybe let's wear PPE so that you prevent contact with a harmful substance. With green chemistry principles, say, can we try and develop the same material or same product using less hazardous chemical synthesis processes? So this is something that is very, very important. And the end goal of it is, let's try to do the same things, but in a way that is not harmful to the planet. So in our thinking, as we develop processes, we need to be very benign, deliberately. Let's look at the same thing, but can we build from things that don't harm the planet? So a very important concept that we need to look at that is associated with green and sustainability is the concept of circularity. So when you look at, let's take an example of a plastic bag that we use or encounter in everyday life. What happens to it? I correctly put it into a recycle bin, and where does it go? Is it going to drop off and end up in the environment or somehow end up in the ocean polluting? Or is it going to go through the right process and end up recycled, reprocessed somehow back into another plastic bag? Is it going to have the same properties? So one way of looking at this through the concept of circularity is, can we take such a material, break it down back into the small molecules that we use to develop this material in the first place, and get back the same material that has the same properties and can do the same function that you wanted in the first place? So this is a very important thing. But it actually brings up a lot of opportunity, because it now means we need to look at new technologies that we need to break down materials and reconstitute them. But in doing so, if we take the example of the plastic bag, the molecules that are used to make such a material would have come from crude oil. You extract crude oil, process it into chemicals. These chemicals are then used to make these materials, like plastic bags, for example. And all of these processes, the extraction, transportation, packaging, putting a colorant into it, all of these processes require energy, and all of this contributes towards climate change. So if we then look at a situation where we can say, we now have this material, can we break it down back into the small molecules and put it back into the original material that has the same properties? Then can it translate into reducing the need to extract more crude oil and reducing the emissions that are associated with all these processes, all these manufacturing processes? So these are some of the thinking that we need to build and engender as you go through your training. And this is important for the health of the planet. So this, in 2015, the United Nations put out the Sustainable Development Goals. These are very important towards achieving some of these goals to improve the health of the planet. And there are quite a few that actually directly speak to some of the goals that we need to achieve through green and sustainable chemistry. For example, clean water and sanitation. I'm sure you've all seen stories of water bodies that are contaminated with chemicals that are no longer safe to drink, or fish dying from all the contaminants that are in these water bodies. What can we do about it? Can we make materials that will help us to purify these water bodies? Can we, for example, develop processes that emit less hazardous gases? Can we make better medicines such that we can achieve the same therapeutic effect without using with much less quantities? So these are very important concepts. So this slide has admin details for the academics who are involved with this module, and you can also, for more detailed information on the requisite courses and the credits, have a look at the yearbook. Information is provided in very clear detail. We look forward to welcoming you in the Department of Chemistry and Polymer Science. Thank you.